Welcome to section 5.4. In this section, we will be discussing some of the patterns that show up when you are multiplying polynomials. All right, objective number 1 is the FOIL method. We will discuss how this works. The important thing to remember about the FOIL method is that it can only be used when you are multiplying a binomial times a binomial. That is it. So it's very specific for this one situation. All right, so the FOIL method, FOIL actually stands for the process that you're going to go through to find the 4 terms that you need. So if you'll notice here, the first, F stands for first, and that's when you're going to multiply the first term in each set, represented in the red here. O stands for the outside, so you're going to multiply the 2 terms on the outside. That's going to give you your O. Your I is the inside or the inner, so you're going to multiply those 2 inside terms, okay, the 2 closest together on the inside. And then L stands for last. You're going to multiply the last term in each set. So that would give you the 4 terms that you're looking for. And you would get the same 4 terms if you use distribution as well. So FOIL is just a shortcut for the distribution method. But again, it only works when you have a binomial times a binomial. So we get those 4 terms, and then as always, we would combine our like terms in the middle to get our final answer here. FOIL, I do like, it does save some time. So if you would like to use FOIL, definitely use FOIL. All right, so let's just practice working through FOIL. All right, so the first thing I do is I write F-O-I-L on my paper so I can be very specific about my 4 terms. So F, again, is that first term in each set. So in this case, y times y, which is going to give me y squared. O is the outsides, so I'm going to do these 2 outside terms. That's my O, right? Y times positive 4 is positive 4y. I stands for inside, so I'm going to do these 2 innermost terms. So negative 12 times y is negative 12y. And then L is the last, so the last term in each set. Negative 12 times positive 4 is negative 48. So there are your 4 terms. And then, as always, make sure you combine any like terms that you have. So there's your final answer, y squared minus 8y minus 48. So if you notice, it does save you a whole line of work that we were doing with the distributive property back in section 3. All right, so if you want to pause and give it a try. All right, let's see if your work matches mine. So first would be 14x squared. Outer would be 10x. Inner would be negative 28x, and last would be negative 20. So there is the 4 terms that I'm looking for in that order, F-O-I-L. We're going to combine those 2 like terms. So my final answer is 14x squared minus 18x minus 20. Here's another example. Go ahead and press pause and give this one a try. All right, welcome back. Let's see if your work matches mine. So first is 2y cubed. Outsides, negative 8y squared. Insides, positive 3y. And last, negative 12. In this case, notice we do not have any like terms to put together. We've got a cubed, a squared, y to the first power, and then our constant term. So this one is done right now. That's it. That's all we can do. No like terms to put together on this one. All right, the second type of shortcut that you can see is when you are squaring a binomial. So anytime that you have a plus b quantity squared, or you have a minus b quantity squared. All right, so normally we would write that out, right? We would use our definition, that is a plus b times a plus b. And then you could use FOIL if you would like. So you would get a squared plus ab plus ab plus b squared. And notice those 2 terms are identical, which is nice. So your final answer is a squared plus 2ab plus b squared. So it turns out that anytime you have this pattern where you have a binomial squared, it's always going to end up looking like this, where you have the first term is just the first term squared in your original binomial. The last term is always this b squared. And then you get 2 ab's in the middle. So you'd multiply a and b and then multiply it by 2, and that'll be your middle term. Same thing works for the negative. Here, let me make that negative sign. If this were a negative, then these would both be negative signs, which would turn out that both of these would also be negative signs, and this sign in the middle would be a negative. So whether you use this, that would be the pattern that you would get. A squared minus 2ab plus b squared. So these patterns are extremely similar. So memorizing this pattern is definitely going to save you a lot of time. So let me show you. All right, so again, if we start with the a plus b squared, we knew that that one came out to a squared plus 2ab plus b squared. So this is a great shortcut to remember. Okay, same thing goes with a minus b squared. That's always going to turn out to be a squared minus 2ab plus b squared. So notice how similar, notice the only difference is the sign in the middle is the same as the sign for the middle term, but otherwise they're completely identical. So I definitely enjoy using this shortcut because it turns super handy, super duper handy. All right, so here are the two typed up nice and pretty, so you don't have to worry about my horrible handwriting. So there's your two patterns. So if you need to pause, write this down in your notes, make sure you have it memorized because you're going to use it quite a bit. All right, so let's use the pattern to do these problems. I know that all of you could write it out and then FOIL it. That's great. But remember, doing math is also about efficiency. It's not just about getting the right answer, but it's doing it efficiently, meaning in the least amount of time possible. So using the pattern a plus b quantity squared. Okay, so this is going to be a squared plus 2ab plus b squared. So write down the pattern, and then we're going to do an evaluating kind of thing. I'm going to take all the variables and I'm going to replace them with parentheses because I know I'm going to substitute stuff in there. All right, and then in the a, so a is the first two sets of parentheses. So in the a position is an x. So instead of an a, I'm going to put an x. Instead of an a, I'm going to put an x. And then in the b position is a 6. So I'm going to put a 6 here and a 6 here because both of those are b's, those last two parentheses. And then all I have to do is clean it up and I'm done. X squared plus 2 times x times 6 is 12x plus 6 squared is 36. So there's my answer. So I used the pattern. I did some substitutions. So whatever was in the A position, I substituted that. Whatever was in the B position, I substituted that. And then I just cleaned it up and I'm finished. So it's kind of like using a formula, right? Start with the formula, plug in what you know, clean it up. All right, so here's another example. Exactly the same thing, just a little bit different. So again, this is still an a plus b quantity squared. So I know that the pattern is going to be a squared plus 2ab plus b squared. So again, take the pattern, replace all the variables with parentheses. So all the a's and the b's. And then plug in what's there. So in the a position is 3x. So 3x goes here, and 3x goes here. And in the b position, we have a 4. So 4 will go here, and 4 will go here. And then all you have to do is clean it up. So what is 3x squared? Now notice we're squaring everything, right? So this is the power of a product rule that we talked about back in section 1. Okay, so 3 squared is 9, x squared is x squared. Plus, middle terms, 2 times 3x plus 4, times 4. So 2 times 3x is 6x. 6x times 4 is 24x, plus 4 squared is 16. So there's my answer. I find that using this pattern is very, very helpful for me. It saves me a lot of time. All right, here's one with a subtraction sign in between. So same thing. This is a binomial, but it's a subtraction this time. So this time the pattern is going to be a squared minus 2ab plus b squared. Okay, exactly the same, except the middle term is now negative because this was a negative. And then I'm going to do it exactly the same way. Put parentheses for all your a's and your b's. And then plug in what's in the a position. And the a position is a 5x. So 5x goes in here and 5x goes in here. In the b position, we have a 2z. So 2z goes here, 2z goes here. Notice we don't worry about the sign at all in front of the 2z because the sign has already been taken care of right there. So you don't have to worry about signs at all. Now we can just clean it up. 5x squared is 25x squared. 2 times 5x is 10x. 10x times 2z, so that's minus 20xz, plus 2z quantity squared is 4z squared. So there's my final answer. 25x squared minus 20xz plus 4z squared. I'm a big fan of these patterns. They save a lot of time. All right, so here's 2 for you to try. So press pause, and then we'll come back and see if your work and my work are the same. All right, so here's all the work. Hopefully your answers and your work match my answers and my work. If they didn't, please go back, take a look, see how you did. Okay, but these 2 patterns are going to be super helpful. So make sure you have these memorized before you take the test. It's going to save you a lot of time. And you will see these patterns again when you get to intermediate algebra and college algebra. So you're going to use them in the future anyway. All right, so let's move on to the next example. All right, so the last pattern that we see sorry, I just had a glitch right there. It's always fun when that kind of stuff happens. All right, so the last objective that we're going to use is finding what happens when we multiply the sum and the difference of 2 terms. So they're going to be the same. So same 2 terms. So let's say we have a plus b and a minus b. Okay, that's what we're looking for here. Same 2 terms, but one is a sum and one is a difference. Okay, when that happens, actually, let me go back to the last slide. Okay, when this happens, again, we could FOIL it out, which again, I don't recommend because it's going to waste time, but let's do it now just so we can see. So if we FOIL it out, we would get a squared minus ab plus ab and then minus b squared. Notice what happens with your 2 middle terms. Okay, notice that they are opposites, so they're going to add up to 0. So all you're left with is a squared minus b squared. So anytime you see this pattern, you can go right to the pattern answer that you know is going to work. So using that pattern is, again, going to save you a lot of time. So here it is again, but typed up because I know sometimes my handwriting can be difficult to read. So there is the pattern that you need to memorize. So press pause, write this down in your notes, make sure you memorize it. All right, so let's do some examples. All right, so 3x plus 4 times 3x plus 4. Notice it fits the pattern, right? This is a plus b, and this is a minus b. So I know my pattern is going to be a squared minus b squared. So the first thing I'm going to do is I'm going to write down those parentheses. Okay, what is in the a position? And in the a position in each of these is 3x. So 3x is going to go right there for the a. And then look what's in the b position. Notice in the b position in both places is 4. So 4 goes there. And then clean it up. 3x quantity squared is 9x squared. Remember, you have to square everything. And then minus 4 squared is 16. So there's your answer. 9x squared minus 16. Use those patterns. All right, so here's 2 for you to try. Go ahead and press pause, give them a shot, and then I'll see you in a moment. All right, welcome back. Let's see how you do. Okay, so first thing I'm going to do is I'm going to write down my pattern. So this is a squared minus b squared. And notice I just start with the parentheses because I already have this memorized. So I know I can start right with those parentheses. In the a position in both, I had a 5a. And in the b position in both, I had a 3. So my final answer is 25a squared minus 9. All right, let's look at b. Okay, again, fits the pattern. Same 2 terms, one's adding, one's subtracting. So I'm going to go right to that pattern, a squared minus b squared. In the a position was an 8c, and in the b position was a 2d. So let's clean it up, and we get 64c squared minus 4d squared. So there are my answers. Hopefully your answers and work match my answers and work. All right, now if there are, and I know I already heard the audible groan from through the interwebs, okay? Just because there's a fraction, don't freak out. Look at the pattern. Does it fit the pattern? Is it the same 2 terms? One's adding, one's subtracting. It is. So I know I can go right to the pattern, a squared minus b squared. All right, what's in the a position? There's an x, so that goes there. What's in the b position? 1/3. All right, so all I got to do is clean this up. X squared minus, what is 1/3 squared? Remember, this is the power of a quotient rule. We're going to square everything. 1 squared is 1, 3 squared is 9. So there's my answer, x squared minus 1/9. So if there are fractions, that doesn't automatically mean it's going to be a horrible problem. So just take a deep breath every time you see a fraction. All right, the next one, this also fits the pattern. Okay, we've got the same two terms, one's adding, one's subtracting. It doesn't matter that the adding is second and the subtraction is first. That doesn't matter as long as one is adding and one is subtracting. So I'm going to write down my pattern and then plug in. So in the first is 2x squared, and in the B position is 6y. So clean that up. 2 squared is 4. X squared squared is x to the 4th. Remember, when you have a power to a power, you multiply. Minus 6 squared is 36, y squared. So there's my answer. 4x to the 4th minus 36y squared. Now, here's the hard part. On the test, we're not going to tell you which one to use. You're going to have to be able to look at it and know. So we're going to try a couple of these special products when it doesn't tell us which one we need to use, because they're not going to give you any hints on the test. They're not going to say, hey, use the pattern. No, they're just going to say multiply, and you're going to have to know by looking at it. All right, so let's look at the first one. 7a plus 4 quantity squared. Okay, we have a binomial squared. That means we're going to use this pattern. A plus b squared equals a squared plus 2ab plus b squared. Okay, so I'm going to start with my parentheses. So a squared plus 2ab plus b squared. All right, what goes in the a position? Okay, in the a position is 7a. So 7a goes here and 7a goes here. In the b position is a 4. So the 4 goes here and the 4 goes here. So clean it up and we'll be done. So this is 49a squared. 2 times 7 is 14. 14 times 4 is 56. So this is plus 56a. Don't forget the a. Okay, plus 4 squared, which is 16. So there is my answer. 49a squared plus 56a plus 16. All right, next one. Next one, same two terms, but one's adding and one's subtracting. So that's going to be a plus b times a minus b. We're going to use, that's going to be that pattern a squared minus b squared. So I'm going to start right with my pattern a squared minus b squared. In the a position was a c, and in the b position was a 0.2d. So clean that up. I get c squared minus 0.2 times 0.2 is 0.04, and then d squared is d squared. So there's my final answer. All right, last one. It's definitely not a binomial squared. This is not the same two terms, one adding, one subtracting. So this will just be a FOIL. Okay, this will be a FOIL problem. F-O-I-L. So let's start with F, first term in each. So y cubed times 2y squared is going to be 2y to the 5th. Right? O, outsides. Okay, outsides is going to be y cubed times negative 1/5. So negative 1/5 y cubed. I is insides, so the inside ones. So 2 times 2/5 is positive 4/5, and then just the y squared. And then last in each one, positive 2/5 times negative 2/5 is negative 2/25. Remember, multiply your numerators, multiply your denominators. And if I look, all of those have different powers, right? 5th power, this is a 5th degree term, this is a 3rd degree term, 2nd degree, no degree. So I cannot combine any like terms, so that is my answer. All right, so those are all the patterns that you might need to use when you're multiplying. So make sure you have these memorized, because you're going to use them a lot, not just in this class, but also in intermediate algebra and in college algebra, and you're going to see them again in chapter 5 and chapter 6. So make sure you know them now, because they're going to come back next chapter. All right, get loose on the homework, and I will see you back for section 5.6.